Hi everyone, welcome to this 11 plus journey video brought to you by myself, Mohi, from the Singapore Maths Academy. Now, today's question is a bit of a tricky one, and we use a unique strategy called the bar model approach. A unique strategy that is very much associated with the Singapore Maths approach. It's not the only country in the world that you use the bar model approach nowadays, especially in England, where I've trained many teachers all across England and internationally on this approach. But for us at Singapore Maths Academy, we're one of the specialists in the UK, if not Europe, on this approach. So I'm really kind of pleased to go through this with you, this question found in an 11 plus past paper. So let's jump onto my board and my iPad to see what the question says. It says Harini has twice as many sweets as Dora. After eating 18 sweets each, she has 5 times as many as Dora. How many sweets did Harini start with? So it's a bit of a challenging question. We don't know maybe how to start this. What do we do with those 18? What do we take it away from? There's nothing to take it away from. You can think of it as maybe a ratio possibly, right? And so the way we would approach this is getting to understand the question in a more visual way. So I've got H for Harini and D for Dora. And I know Harini has twice as much as Dora. So I'm going to represent Dora's sweets with this bar. How would I represent Harini's? She's got twice as many, right? And so we have two of those exact same bars. So what I'll do, I'll just copy this out here. So to make an exact fit, I'll duplicate and I will add like so. So now I've got Harini, who's got twice as many sweets as Dora. And I can see that I've fulfilled the first part of this question, which is to represent Harini having twice as many sweets as Dora. But then something happens, right? Something happens, which is they both eat 18 sweets. So I have to subtract 18 sweets here. So I might just show the subtraction of 18 sweets like this. Okay, so I've got 18 sweets taken out, but they both have 18 sweets each. So I know they both have 18 sweets each. And after having 18 sweets each, what happens? She has 5 times as many as Dora. Okay, so 5 times as many as Dora, that means that, oh, well, how am I going to represent that in this bar, right? Is there a way? I know this part of the bar is equal to this part of the bar because they both have 18 sweets and they're exactly the same bar. And so that they're both equal. Now, to represent 5 times as many, that must mean I have to have 4 equal parts here. And these equal parts must be the same as this part here, because now I can see that we have 5 equal parts to represent, oops, excuse my poor bracket there, 5 equal parts to represent my 5 times as many. 5 equal parts there, and you've got 1 equal part here, and that's my 5 times as many, right? Dora has 1 part, Harini has 5 parts. I can see that Harini has 5 times as many sweets as Dora. And also, don't forget that this part here must be 18 because they both have had 18 sweets. Okay, so does that help me in any way? Can you see what to do next? Is it possible to solve this question with this strategy so far? I know that these are the same, so I'm just going to highlight them just to make it a bit clearer. So I've got 5 equal parts here and 1 part at the bottom, which is also equal. I can see that this whole bar has 4 equal parts, and that must mean that all of these big bars, the larger bars, must have 4 equal parts as well, right? So I've got 4 equal parts here. Now I can see that the 18 sweets that they've eaten and they've used must have been equal to 3 of these equal parts. And so if they're 18, this must be 6, 12, 18. This must be 6 each. And if they're 6, and we know they're all equal parts here, then these are all 6 here. And so at the beginning, Harini and Dora must have had this amount. Dora must have had 18 plus 6, 24. Harini's got double the amount that Dora has at the beginning. And so what we're going to say is that Harini has 24 times 2, which is 48. Let's see if that works. Because one of the key things about maths, once we've got an answer in this type of question especially, is very simple to make mistakes, but also it's very simple to see if you've actually answered the question correctly. So let's have a look. If it's true that Harini has got double the amount Dora has at the beginning, then 24 times 2 should be 48. Yeah, so far so good. If they've had 18 sweets each, 48 take away 18 equals 30, and 24 take away 18 equals 6. And now Harini has got 5 times as many sweets as Dora. 6 times 5 is 30. Yeah, it works. And so therefore Harini must have had 48 sweets at the beginning. And that's what the question is asking us. How many sweets did Harini start with? She had 48 sweets at the beginning. So this bar model approach just allowed me to easily make the jumps that I needed to make to understand this problem in a more simplistic way so that I can solve this question. A very visual way that I can make sense of myself and I can make sense of with my children when I teach them. Now, this approach is not exclusive to us, but we are experts at this approach. We train teachers across the world on this approach. So if you wanted to take advantage of our expertise, then do contact us for more information about our courses on the bar model approach and how it can help your child or children to master maths and problem solving. Because we all know that in 11 plus exams, the trickiest part is the problem solving, not the arithmetic side, because we all can do the addition, subtraction, multiplication, division by this stage. Well, most of us should be able to, right? But the part that's tricky is combining them and also deciding when to use what, and sometimes even what to use in problem solving questions. So if you want to take advantage of our expertise, do contact us and we would love to speak to you about our courses to support your children. Take care, everyone. Bye.